Was already started. Hello students, we have started our first lesson, that is the rotational dynamics. All of you have already joined introductory lecture of this rotational dynamics. We have seen there in the rotational dynamics two types of motions are there, that is a uniform circular motion, and second type of motion we have seen there, that is non-uniform circular motion. In this case, we can observe uniform. In the case of uniform circular motion, you have studied there the motion of the particle is along with a circle with uniform constant speed. Again, we have seen there, that is whenever it is moving along a curved path, it is having a uniform speed. If sometimes I have used vehicle and along with the vehicle I am going to on the road, then you can observe there each and every vehicle is having a different time. So that whenever we can observe it in the case of that vehicle, you can see there, that is the part of that can be travel along with the road. Maybe it is with the variable speed. So we have already bifurcated that in the form of uniform circular motion and second type, that is non-uniform circular motion. We have to see today the application of uniform circular motion as well as non-uniform circular motion. In this case, if we have considered a vehicle, if I have considered vehicle which is traveling along the path, then it is having the different speed. Whenever along with a circular path it is revolving, then you will observe there the centripetal force is acts over there. Towards the center it is active. And that's why we have seen one of the force which is acted towards the center. It is also called it as the centripetal force. These are some of the revision points we have already studied. In the 11th standard, you also know that the frictional force is also there whenever any two bodies are in contact with each other. So suppose these two bodies are in contact with each other, then we can see there exists a force which is called it as the frictional force. So in this case, the frictional force is also observed there, and we can see that frictional force in the form of coefficient of static friction in the 11th standard. And now we have to observe that application, that is a banking of road. So what happened in the case of curvature, whenever you are traveling along a curved path or curved road, you have to apply some of the force, which is a fixed force you have to apply. So if you have a less force than the required force, then you can't travel it along with a curved path. If the force is greater than the required force, then the vehicle may be skid off. We have to maintain some of the force due to the tires and roads. One type of forces exist there. What is the name of that force? I told you just now, whenever the two particles are in contact with each other, the frictional force is started there. Due to this, maybe one type of tangential forces exist in between these two contacts. So obviously, whenever the vehicle is along with the road, then the two type of forces are there. We are only thinking on a turning road because we are going to study here, that is a circular motion. And that's why you have seen some of the roads are curved like this. And on the curvature, the speed limit is written over there. we have to see what is the speed limit and what is the requirement to avoid the skid of that vehicle. व्हेकल रोडच्या बाहेर जाऊ नये याच्यासाठी काय रिक्वायरमेंट आहे ती आपल्याला बघायची. Okay, so that is called it as that requirement which is already there on the road. What are that requirements on the plain road? If the turning point is there on the plain road, then maybe the vehicle is skid off, or maybe it is not traveling like this. If you are at the less speed of vehicle, then you will know that vehicle is not passing through that road. But here we have to see there the arrangement is required over there. Due to that, we can see the safe traveling of that curved road. What is that requirement? That is, you have to tilt that road like this. And whenever the road is tilted like this, some of the angle is required. That angle for safety driving, we can call it as banking of road. So imagine that one of the vehicle is along with a curved path. Means on the curved road, one vehicle is there. We have to go through that curved road. What can you do? Maybe the speed limit is fixed over there. It is already written on the road. This thing is already there. The banking of road means the road are made with such type of angle. What is the value? How can we identify what is the value of this angle? That I am going to explain here. This is the first application called it as banking of road. Imagine that this is a vehicle and it is moving along a curved path. Two types of forces are acted on the vehicle. First, we have seen there that is the weight of that body, means the gravitational force is acted on every body, you know that. So this is the gravitational force which is acted on that body. The weight of that body, how can we calculate? It is a product of mass and gravitational force. So it is a product of mg. This is balanced with some of the normal reaction. And that normal reaction is balanced with this force is called it as M. It is resolved into two components. Why we have seen? Because we have to consider two type of forces. So that this N is resolved into two components, N sin theta, N cos theta. N cos theta is balanced with the force of mg. N sin theta is acting towards the center. Because this is a curve part, and that's why it has some center over there, and we have to see that force is acted towards it. So whenever this force is acted towards the center, we can see these two components of the normal reaction. When we equate this component, you will get the resultant normal reaction. And that's why n sin theta plus n cos theta will give you the value of m. But here, that is not our aim to find the components and the vector, what is the normal reaction. This is not our aim. What is our aim? That is, we are going to find out the angle that is called it as banking of rows. This is the required angle, and you have to solve some of the problems based on it. So first time we can see that this n cos theta is balanced with the force, n sin theta is towards the center of that force, and the centripetal force we have seen there, that is equal to mv square upon r. So when these two forces we have considered, it is a upward force. This is a force towards the center, and that's why that two forces can be written like this. N cos theta is equal to m into g. It is a weight of the body. So obviously any object is having weight of that body which is balanced with the normal reaction. Secondly, n sin theta is a centripetal force. Means it is acted towards, see this diagram, in the diagram it is already given in this direction. So towards the center it is active. And that's why n sine theta is equal to mv square upon r. We have already studied in the 11th standard. Same thing I have written first equation for the first reaction. Second force can be acted on that one particle is the mv square upon r. I am going to divide this equation 2 by 1. What is getting n sine theta divided by n cos theta? Second divided by 1. mv square is the value of this because it is the force acting towards the center. N cos theta is equal to mg. Only the values are substituted there. So that what happened here, n will get cancelled. You have studied sin theta upon cos theta in trigonometry. It is equal to tan theta. So this tan theta is left over there. This m and m will get cancelled. And we can write this equation. This g will be transferred here in the numerator and it can be written there. Tan theta is equal to v square upon rg. This equation I am getting there because our aim is that I am going to find banking of rho. That's why I must know that the value is in this way. So tan theta is equal to v square upon rg. What is the meaning of v square? It is the speed required for that vehicle. Secondly, what is the meaning of r? That is the radius which is calculated from the center. G is the gravitational force. So this tan theta is equal to v square upon r. By using this equation, I can find out what is the angle required for safety driving. Theta is equal to tan inverse v square upon rg. Is it clear? Inverse factor we can take it there. And that's why to find this theta is called it as banking of force. This equation I got it. Theta is equal to tan inverse v square upon rg. Accordingly, I can find it. So if you have seen this equation, you will get the clear idea about it. The mass is absent. Is it depend on mass? Banking of roads, while you are going to study the angle, to find the angle, it is independent of mass of vehicle. And that's why on the road, any type of vehicle can travel over there. And that's why while it is moving along a car path, the mass is not considered. And without considering the mass, we can make the arrangement. So this is what the factors which we are going to see is the first part, application of the non-uniform circular motion. Secondly, again I am going to tell you one thing, that is two forces we are going to consider. First is what? That is the normal reaction. Second, that is a force towards the center. Third is already there, but we are not considering in this case. Which type of that third force? That is the coefficient of static friction. Coefficient of static friction is already there. But we are not considering in this case because we are getting the equation by using these two type of forces. So whenever we are considering a force related to that one, it is considered in dynamics. So in the dynamics, we are considering the forces. So actually, these are the forces. You know that the gravitational force is also a type of force, and that's why this is the type of forces which we are considering in dynamics. Second application is also given there, that is conical pendulum. What is the meaning of conical pendulum? If I have given one of the heavy bob, I have attached it with the stand to the string. That string is having weightless string and inextensible. That type of string if I have used there, then one factor we can see there that bob is suppose connected here. Then we can observe there whenever that bob is used over there, then it can be like this. So suppose this is a string attached with this, or we only in normal case you can consider one of the thread. One thread if you have attached with a heavy bob which is fixed at one of the support. So the same arrangement I will show you here. This is the support, one of the thread if you have considered. That thread is like this. This is the bob which is considered at the center. Along with this in three-dimensional case, I am considering it. And that's why horizontally it is traveling along this one path. Suppose it is moving along this path. Along a circle it is moving. Then I can draw that diagram like this. This is the bob attached with the support. Height is h. Then the two type of forces. If this bob is at this position, I am considering what are the forces applied at this situation. That is, the bob is here when after sometimes if I have given the oscillation. So that when it is moving along a circle, in a circle, and that's why it is also a circular motion, so that these are the forces. So what I am telling you, remember it always. In this case we have considered two forces. Same two forces are we have to apply here. In the case of this, you know that whenever I have attached something with that thread, then it has some of the weight. Is it clear? There is no doubt because every particle which is on the earth's surface is having weight. So this weight is called it as mg. In this case, whenever vehicle is along with the curved path, mg is the weight. Here also the same thing is there, mass into gravitational force. It is balanced with normal reaction N. But we are considering this in the form of two factors. So that t cos theta and t sin theta are the two components like this. In this case, we have to see t cos theta mg, t sin theta towards the center of that, and that's why we can observe towards the center, but that distance is equal to r. And hence, here also the two type of forces is there. T cos theta is equal to mg. Here we have also seen there it is in the form of not a T. Tension is not there because this is not a thread. It is a vehicle. But here on the thread, tension is acted towards the support. And that tension is divided into this normal reaction as well as the centripetal force. In this case, we can see this diagram. This is called it as the conical pendulum. And we have to see there which type of forces are acted on that conical pendulum. So the first force we have seen there T cos theta, which is balanced with the force mg. Second force having the component means second force towards the center is also lies there. And that's why in this case we can observe T sin theta is equal to mv square upon r. In case of that centripetal force, also we have studied in the introduction that can be also written as mr omega square, where omega is the velocity. It is angular velocity, and you can remember there that is the linear velocity is represented by vector v. Angular velocity is represented by letter omega. What is the difference in between these two? Angular velocity, while we are considering along with the circular path, then it has some velocity. It is always acted at the center. So that along with this axis only it is there. And that's why we have seen there delta theta, alpha and angular velocity omega always lies on axis. Maybe body is along with the clockwise direction as well as anti-clockwise direction. The direction is immaterial, but it is always acted along with the axis. What is the meaning of velocity? Already you have studied there. It is a displacement upon time. When the vehicle is traveling along that, linear velocity we can calculate. But here only we have to find out it is for this conical pendulum. And only the difference I have explained here, V and omega. Along with it, we know that the two factors can be considered. N cos theta is balanced with mg. N sin theta is balanced towards the center. And third force is also there, but we are not considering in this case. Third force also we have to consider. That is, there exists a friction between tire and road. That frictional force is also considered in some of the derivation. But here that is not a road and tire is given. Now we have to find out this force like this. N sin theta, T sin theta as well as N sin theta is in the form of same case we have to use it. So that T cos theta, T sin theta like this. I am going to divide second equation by first equation. T sin theta upon T cos theta is equal to, substitute the value here, mr omega square upon mg. What is left over there? That is Ca. In this case, m will get cancelled. This T will get cancelled. Sin theta upon cos theta is equal to tan theta. R omega square upon G is left over there. R omega square upon G. So this is what tan theta is equal to the equation. But if I want to find out the angular velocity, then omega square is equal to G tan theta upon R. G tan theta upon R means I have shifted this G here and divided by R. Because I am writing the equation for omega square. Omega square is equal to G tan theta upon R, and therefore omega is equal to under root of G tan theta upon R. Now the value of omega we have seen there in the revision point of view. That is the first point. That is, along with one circle, whenever any one object is moving, then someone is having that video off करायचा है. कोण आहे हा मुलगा? 12th A. Off your video. Those who are having the video is on there, off your video. व्हिडिओ ऑफ करायचा आहे. कोणाचं चालू आहे? हे बघा कोण आहे. Okay, so omega is equal to 2 pi upon T. If I have substituted the value, then 2 pi upon T like this, G tan theta upon R.
Everyone has to make the video invisible. Your video should be turned off.
Now from the figure, we can write R is equal to, here R is equal to L sin theta, where L be the length of the spring and H is equal to height can be written as L cos theta. If we have substituted the values, then T is equal to 2 pi under root of H upon G. H is the height, G is the gravitational force. But we know that height H is equal to L cos theta. If we have substituted the value in the equation, this can be written 1 upon T equal to 1 upon 2 pi under root of G upon L cos theta. So to find the frequency of that conical pendulum, then we can write it as 1 upon 2 pi under root of G upon L cos theta is the equation for frequency. So these are the uses of that centripetal force and centrifugal force. Now, which we are considering in both the ways. So these are the derivations for the banking of floors, and second type of derivation is there for conical pendulum. After this derivation, if you have studied why I have taken it in the combined way, that is due to that we can see here in this case the derivations in a very simple way. You can remember both these derivations properly, and so that we have to find out the required derivation. In this case, we have seen there the angle required for safety driving, it can be calculated by this equation. These two equations are very important from the first lesson, that is circular motion. And that's why for our simplicity, whenever you are going to study the factor, then you have to use here that in the case of this, we can observe it, and so that you have to use this in the simultaneous way, remember it, and that's why we can observe it in the way. Secondly, some of the solved examples are given there in your book. I am going to post the same thing, that's derivation in the notes. You have to write down the notes. First factor you have to remember, it is nothing but write the notes. Write the notes properly. Remember that derivation by your method. But if simultaneously you can remember it, then it is better. So that's why I have given these two applications in the same way. Third is also given there. Death of whale. In that case, what happened there? You have already known that. Along with this, one of the vehicle is traveling. But maybe it is in the reduced syllabus. We are only giving to that one introduction. Whenever it is also considered, these two type of forces are there. In the case, if it is along with the circular path moving with this one, then it is given along with this path and the forces are acted on it. Anyway, the forces are acted at this center point, towards the center. So in this case, you have to increase the force and increase the force, sufficient force required for that vehicle. It is also the force adjusted towards the center. And that's why whenever the vehicle is moving along a curved path, it is also nothing but the circular motion. And along with that circular motion, we can see the speed limit is also there. The same thing is again repeated. So that required speed, when you can catch it, at that moment only you can cover this radius. At certain height, maybe it is changed, it is not depends on height. And along with that, when it is travel with a specific speed, same factors can be used. And this is what nothing but the same two type of forces can be observed in. Okay. So I will give you the notes. You have to write it in your notebook. Complete the notes properly, and then we will see the part. If any doubt is there, I think that nothing is there. Doubts are required for it because so easy things I have explained here, and you have to remember all these things. Okay. In the next lecture, we will start the remaining part.
I am closing the meeting. I am closing the meeting for everyone. येतच नाही. ऑटो ऑटो बंद झाले.
ऑटोच होते वाटतं ना
ऑटो बंद झाले.
अरे तो